Hi all, my name is Catherine, Assistant Professor from the Department of AML, SNS College of Technology, Coimbatore. So today in our lecture series, we shall see about the substitution techniques. So in earlier video, we saw what are the network security model, and I told you there are certain algorithms and techniques will be used for converting this plain text into ciphertext. Under that algorithm or techniques, one of the techniques is substitution techniques. So under these techniques, we have different types of substitution techniques, and today we shall see about the Caesar cipher. So substitution technique is one in which the letters of the plain text are replaced by other letters or numbers or symbols. As I told you earlier, here we are going to substitute one letter with another word, another letter or another number or symbol. So simply instead of H, hello, shall we meet tomorrow? Instead of H, you can either substitute H with a number, you can either substitute H with another alphabet, like instead of H, you can put Z. So that key should be known between the sender and the receiver. So under this substitution techniques, we have various types of techniques. Today we shall see about the Caesar cipher. The easiest, the earliest known and the simplest use of a substitution cipher was by Julius Caesar. The Caesar cipher, this was actually by the Julius Caesar. So what he did was it involves replacing each letter of the alphabet with the letter standing three places. So he took a three shift to the original letter. So I should show you here. So for this table, this plain text and cipher text is like, what he has taken is for every alphabet in the plain text, he has taken three shifts. So for instead of A, you can put it as a column for better understanding. Instead of A, after three shifts, what do we get? A, B, C. And what is the next letter is D. Instead of B, we are getting E. Instead of C, if you take three shifts, C, D, E, then what comes? F comes. So I have put it as a tabular column for better understanding. So what Julius Caesar did was, here you could see there is a plain text which says pay more money. So instead of P, what letter is coming? S is coming. So he has taken three shifts. Instead of A, what letter is coming? D is coming. Instead of Y, it is what is coming? B is coming. So after you encrypt the entire message, how does it look like? It looks like SDB, PRUH, PRQHB. If when you see this message, ciphertext, is it readily readable with your naked eyes? No, right? We do not, definitely will not be able to understand what is that. Instead, pay more money is way far different compared to what the ciphertext which we received after putting this substitution technique. So this is one of the simplest and the easiest message. So when in this way, you can send a secure message from one end to the another, but it is not necessary that you have to take only three shifts. It's not necessary you have to take only three shifts. The shifts could be of any number or any number. You can take either 5 shifts or 6 shifts, but Julius Caesar took 3 shifts. So the algorithm, the equation goes like C is what the ciphertext. For each plain text letter P, substitute the ciphertext letter C such that C is equal to encryption of plain text. How do we encrypt? We are taking P plus 3. We are taking 3 shifts mod 26 because the alphabets is always 26. No, the shift may be of any amount so that the general Caesar algorithm. So generally you can put it like this three, the shift you are doing, three shifts you are doing, right? That is called the key. So when the receiver receives this message, what he will do? The decryption part is just the reverse of encryption process. So if you are taking shift to the right side of your letter, here you have to do it the shift in the reverse way. For if you're doing the shift in the forward way in the encryption, in the decryption, the decryption should be done in the reverse way. So here how the decryption is being done, in order to get the plain text, what you have to do, you have to put the ciphertext inside a decryption algorithm. What is that decryption algorithm? C minus K. C is nothing but the ciphertext minus K, means you have to take three shifts in the reverse order, not 26. So this is how the encryption. Now I think you will now have a little understanding of what actually happens. No, this plain text is suddenly changed into a different format, which you did not even know with your naked eyes. You cannot even predict like what he has done, whether he has taken three ships. We immediately we won't be able to judge whether what is that. It is not. It will feel like it doesn't give any meaning, right? So there are chances like the attackers could discard and go. So this way you can protect or you can secure your message so that this is one of the ways of providing confidentiality, because this message will not be able to will not be able to be read by anybody who comes and reads that message. So without knowing the key, here the key part is what? Taking three ships or any number of ships. Julius Caesar has taken three ships. In this example also we have taken three ships. So this equation is all about the encryption part, what it happens, and the decryption part, what it happens. In the forthcoming videos, we shall see about the many more substitution techniques under the substitution techniques. I hope you all understood. Thank you.